Hello everyone and welcome to this video on Transistor Transistor Logic. This is a series of videos which you are watching under the course of Digital Design BTech course for the students of 4th semester EC Electronics and Communication. First we will discuss about what is the TTL. TTL stands for Transistor Transistor Logic. So over here in this logic family, this logic family is mainly built up using of NPN transistors, PN junction diodes, and some diffuse transistor resistance. And the basic building block of this logic family is called as is a NAND gate, which will be there. And there are different forms of TTL gates. And there's a logic families have been developed. One of the families is standard TTL, advanced shortcut TTL, low power TTL, high power TTL, fast TTL, and open collector TTL, and tri-state logic TTL. Like that way different logics are present. Will be there in this video. I will try to cover it on standard TTL. So before going to that one, first of all, we'll have the difference between DTL and TTL and how the improvement is done in the DTL to TTL. Very this TTL is one of the logic which is being used for the generations which are using small scale integration or medium scale integration. This is one of the most important technology which is used, and it has been prominent over there, and we have seen the good performance of this TTL compared to the speed of operation and other factors. The major drawback in the DTL was speed of operation, and you were unable to get the exact output at exact time. So, DTL has taken into consideration and has been there. So, there was a speed limitations in DTL. So, the basic gate of DTL will be there, it will be showing the improvement in the circuit. So, this is the standard DTL circuit, which is there. And this circuit is also called as totem pole configuration. So here, one thing I want to tell you over here is that in this circuit, this part just an input which are being provided to this one, and this for TTL circuit you would be having a special transistor called as multi-emitter transistor. The detailed description about the multi-emitter transistor would be given in the self-learning video. SLT topic video would be given, a short video. It's not a big task. So here in this one, you would be having one collector and multiple emitters would be there. That would be there. And then the power supply rating would be some 5 volts of VCC you would be providing to that circuit. And logic low would be zero point 0.2 volts, logic high would be 5 volts. And you can see over here, this would be your switching transistor. Q4 will be the transistor which takes into switch the current from low to high, high to low. This would be that. And this circuit, the outermost circuit, we say it as totem pole configuration. Here you would be having these two will be acting as an resistance, and when the input is when the transistor is charging from 0 to 1, this would be just like very low resistance would be there. And when the transistor is cut off, to avoid damage to the loads, this would be transistor Q3 would be out of, and it would be the saturation voltage would be there. At that moment, we say this transistor would be totally cut off and it would be on, and you would be having a saturation voltage. So it would be acting as a high resistance. We'll see one after the other circuit over here. Um, Remember, this is an standard TTL configuration, and in this configuration, what you can see is that transistor logic uh, totem pole configuration, or we can say one more name we can say is that pull-up circuit. This is the pull-up circuit, and this is the pull-down circuit. This is your phase splitter, which splits the output from zero to low. Middle portion is the phase splitter, and you in the starting you would be having multi emitter transistor, which takes the inputs over here. So coming to the configuration, when you are providing inputs as low and inputs as high, how the circuit behaves over here, we'll see that one. Consider the case when both the inputs are low, or when one of the input is low. As it is NPN transistor, what happens when you are providing one of the input as low or both the inputs are low? These emitter base junction is forward bias. So here emitter base junction is forward bias. So it's established. This is just like a diode. This is N and this is P. This point is an okay. This is your P point and this is your N point. So here this establishes this is just like an diode will be there, and here they're establishing a path from here to here. Voltage will be changing to these diodes, and so this would be making there would be no collected current, and this way there will be no flow of this one, and to the base of this transistor Q2, you won't be getting any current flowing to that one, and this is off. When this is off, it is being connected to the emitter. So this transistor Q4 also is off. When Q2 is off, Q4 is off, and this transistor is cut off means, and at the same time, this transistor Q3 is on. How it is on? You can see the start time to be sufficient time to be going to the place of this. So when this is going, this is conducting, and it has a closed. So the total VCC, it charges the VCC towards from zero towards the VCC, not charges towards the VCC, and output becomes high. This is the case when both the inputs are low or one of the input is low, you would be having the same configuration. When one of the input is low or both the inputs are low, you would be having the same configuration. Output would be high. And now let's say when both the inputs are high. When both the inputs are high, what happens in this circuit? So when you are having an input as high, when the input is high, what happens is that emitter base junction is reverse bias and collector base junction is forward bias. So in this multi-emitter transistor, where emitter base junction is reverse bias and collector base junction is forward bias, in this particular situation, emitter behaves as a collector and collector behaves as an emitter. Now here, at this moment, in this moment, you will be having this would be just like an emitter, and this will be just like a is nowhere. Now when when inputs are high, when both the inputs are high, they would be this would be like a current. So you know that the property of the emitter, the current would be flowing out of the emitter. So there would be a sufficient current, and this is no way, there is no path over here. So you would be having a sufficient current flowing to the base of this transistor Q2. So when there is a sufficient current flowing to the base of this transistor Q2, so here this Q2 will make this transistor Q4 to be on. And here this will be establishing a path to the ground. There won't be any high voltage flowing to the base of this transistor Q3. There won't be any current flowing to the base of this transistor. Major portion of the current will be flowing into this circuit, and there will be very little current, and this transistor Q3 gets off. So it is an open switch. So what is the voltage appearing in the output? It is the saturation voltage of the transistor. So this circuit will behave like an TTL, and this one middle portion of the circuit is, once again I'm telling you, it is said to be a space splitter. This is called as an totem pole configuration, not a part totem pole, and this one is the multi-emitter transistor. And one thing you need to remember, when one of the input is low or both the inputs are low, emitter base junction is forward bias, collector base junction is reverse bias. When both the inputs are high, emitter base junction is reverse bias, and there won't be any current going to the base. Let me say, um, there the emitter base junction is reverse bias, and emitter behaves as a collector, collector behaves as an emitter. Because there's sufficient current, and it flows to the transistor Q2, and this is Q2 is on, and simultaneously it would be a sufficient current flowing to the base of this transistor Q4, and this Q4 is on. This behaves as a circuit as an TTL line. So in the next video, we'll be discussing about Schottky TTL as well as open connector TTL and tri-state logic TTL. Thank you for watching.